Welcome and thank you for joining. In this lesson, we'll explore the product rule in differentiation. So I'll take you on a journey with me to proving the formula first. But what is the product rule? The product rule in differentiation helps us determine the derivative of a function given in product form, or in other words, if we're given the product of two functions or more, but we'll start with two, and we want to differentiate it, that there is a formula that can help us find the derivative more efficiently and more easily. So I'm going to take you on a journey first to discovering the formula or to proving this very formula. So we're going to say that if we are given a function f of x multiplying g of x, we start off by giving it a single name. So we're going to call this capital F of x. And to find the derivative of f of x times g of x means to find the derivative of this single function. So guess what? We're going to prove this by the one and the only, the first principles formula. So we'll say that the derivative of f of x or f prime of x equals the limit as h approaches 0 of f of x plus h, this f, right, the capital, minus f of x divided by h. So next, we are going to bring f of x and g of x into the first principles formula. So we're going to say that would be equal to the limit as h approaches 0 of, so instead of f of x plus h now, we have to replace the x by x plus h, which means that this x here will become x plus h, and this x in here will become x plus h. So that would be f of x plus h multiplied by g of x plus h, and then minus f of x. Now, f of x is right here, so fx gx. So we will subtract f of x times g of x, and all of it will be over h. Now, obviously, as you can see, we cannot substitute h by 0. It's too early, it's too soon, because substituting by 0 is complete failure. And we will try to follow a different approach. So we have to start becoming or getting a little bit more creative. So we will change the face of this expression in such a way that it becomes somewhat familiar. It becomes something that we can replace it with, something more meaningful. And the way we do this is by adding and subtracting the same term into the numerator of this function. So remember that when we add a 3 and subtract a 3 from an expression, that means you're adding and subtracting 0. So basically, you haven't changed the value of the expression. So in this case, what we're going to do is we're going to add a term that contains one factor from this group and one factor from this group of products, right? The reason why is because we want the term added to have something in common with each group of terms that we have in the numerator. So in this case, what I would do is, obviously we have the limit as h approaches 0, is pick one of the factors here. So I'll say f of x plus h from here and g of x from here. But it doesn't really matter. You can pick g of x plus h and f of x in here. So it is important to pick two different ones. And the reason why, as I explained before, is so that the term added into the or introduced to the expression will have something in common with both groups of terms. And I'm going to start off by implementing the idea that I just explained. And I choose to add and subtract f of x plus h g of x. So I'm grabbing this from here and g of x from here. So we are subtracting and adding the same thing, and then write the rest of the expression divided by h. So we need to extend this fraction in here and then divide it by h. Now you're probably wondering, how did you come up with the idea of adding and subtracting the same thing? So we always take things personal when it comes to thinking, because we want to internalize what we see or what we are introduced or what we understand. Now, I want you to remember that these formulas, these theories were not built in one day. So there were years of persistence and hard work and a lot of imagination that were implemented or were incorporated or contributed to the birth of these ideas and these amazing formulas. So for now, what we're going to do is try to understand it. And everyone will take the thinking a little bit further to make things a little bit more perfect. And that's how each and every new discovery is built on previous discoveries, understanding the previous ones. Anyway, so long story short, we're going to continue now with proving the theorem. Here we have the limit as h approaches 0. And this is where we're going to start working with this expression and changing the face of it and giving it a complete makeover so that it brings something familiar in front of us. So I will start off with the first group of terms in here. As you can see, they have in common f of x plus h. So I will factor out f of x plus h, and then in brackets we'll have g of x plus h minus g of x. Close the brackets. We still have plus, and here we have a common factor of g of x. So g of x is coming out as a common factor. And we have f of x plus h minus f of x in here, everything divided by h. So remember that one of the limit properties is that if we have, say, for example, the limit as h approaches 0 of f plus g, we can split this into two limits. So limit of as h approaches 0 of f plus limit as h approaches 0 of g. So we're going to do the same thing in here. We have the sum of two big terms in here. And another thing you have to remember, or we have to remember, is the denominator. Remember that if you have 2 plus 3 divided by 4, sorry, I'm going to make it 2 plus 3 divided by 4. If you split 2 plus 3 over 4, then both terms in the numerator will get a 4. So 2 over 4 plus 3 over 4, because that's how addition of fractions works, right? So we're going to start by writing the limit as h approaches 0, f of x plus h times g of x plus h minus g of x divided by h, and then plus the limit as h approaches 0 of g of x times f of x plus h minus f of x divided by h. So we have split this limit into 2. Now, the next thing I want to bring to your attention is this multiplication. So, according to properties of limits, if we have the limit as h approaches 0 of f times g, so two different functions, so that would be the limit as h approaches 0 of f multiplied by the limit as h approaches 0 of g. So what that means is that we can split this product into two limits. So the limit of a product is the product of their limits. And another thing I want to bring to your attention so we won't forget is the fact that here we have multiplication. And if we are splitting a product, so if we have, say, for example, 2 times 3 over, 7 here. So remember that when we split this fraction, right, into two factors, only one of them will get the denominator, right? Because that's how multiplication works. So tops to tops, bottoms to bottoms, we said, right? So we're going to start to apply this idea here. So we have the limit as h approaches 0 of f of x plus h now times the limit as h approaches 0 of g of x plus h minus g of x divided by h. And then we still have plus. Again, we're going to split this product into the limit as h approaches 0 of g of x multiplied by the limit as h approaches 0 of f of x plus h minus f of x divided by h. So you probably recognize the little miracle that happened in here. So we have g of x plus h minus g of x over h as h approaches 0. And this is when I get an aha moment in class. Almost every time we talk about or we go over the proof in here, said I have students that just point at the screen and say, I see a derivative, I see first principles in here, and yes, that's what it is. So let's celebrate the birth of the first principle formula here in this equation. And as you can see in here, this would be simply the derivative of the function g, so this entire thing. So, and the way we know it is because that's a first principle formula for finding the rate of change of function g of x at any point, or the derivative of function g of x at any point, or g prime x. Now let's take a look at this term in here. We have the limit as h approaches 0 of f of x plus h. Well, what would happen if we replace h by 0? So we have x plus 0. That's what happens, right? So we're going to have the product of these two. And obviously we have a plus. And let's take a look at this. Again, you recognize the formula, first principles for the rate of change, instantaneous rate of change of f of x at any point, or the derivative of f of x. So this entire thing represents f prime of x. So we'll write that down here. And let's take a look at this other term in here. So the limit as h approaches 0 of g of x. Notice how g of x doesn't even depend on h values, which means that that would be equal to g of x. And if I can recall here, let's say when we said limit as x approaches 2 of number 5, well, number 5 is number 5. It doesn't depend on x. So it's like a limit of a constant in a way. So we're going to write in here g of x. And voila, this is basically the derivative f prime of x. Or should we say, this is the derivative of f times g. And I like to write the formulas in a, decluttered way, because that's how we memorize them better. And we got to do what actually works best for us, right? Within principles, always. And you see that here we have f of x plus 0, which is basically f of x, and then multiplied by g prime of x. Oops. I'm going to leave it in a neater form, as we said. So f times g prime, and then plus, because we have multiplication here, right? And first we're going to write g and then f prime. Oops, I'm mixing up the colors very badly. So g times f prime. So as you can see in here, what we obtain when we have the product of two things differentiated, we get these two things repeating in two terms, but here you get the derivative of one of the functions, here you get the derivative of the other. And I wanted to bring this to your attention because we want to actually derive one very, very, very important extension, I would call it, of this formula. Let's say, for example, that we have the product of three functions, not just two, but three functions. I'll do this very quickly here. So if we have f times g and we're trying to find the derivative, the way I memorize the formula is I have two functions, so I'm going to write f times g twice and they're added. And here I'm going to differentiate the first, here I'll differentiate the second. Now, if I had f times g times k, so if we had the product of three functions, we wanted to differentiate them, then we're going to say the derivative would be fgk. And since we have the product of three things, we're going to write fgk three times. And they're all going to add to each other. And here we take the derivative of the first, here the second, and here the last one. And if you can go for, or if you want to find the derivative of the product of four functions, the same pattern follows. So I hope that you enjoyed the journey with me, discovering the product rule of the derivative of a function, or the derivative of a product. And I hope you found this interesting and fun. And thank you for learning with me, and have a wonderful day. Bye for now.